All right, so today we are going to look at, we're still looking at recursion and we're looking at financings, but today we're going to look at linear decay. So types of linear decay, so that was when we had our, say, our value of something, and we've been saying over, say, n periods. Decay was when it's going to go down, and it will go down in a straight line because it's linear. So what that means is that the same amount is being taken away every time. So, and that's when you'll learn. So there's two scenarios that we will do for linear decay, and one is flat rate and the other one's unit cost, and that's what we're going to do today. So with flat rate, so you have a constant amount subtracted from the original value, and you can see here in the flat rate recurrence relation. So remember I said when you have a VO and a VN plus 1, that makes it a recurrence relation. So this is flat rates recurrence relation. And that D is the same amount, the amount that's always getting taken away. So, and with decay, it's minus. So with simple interest, it was adding. So with that same amount, the D value, you've got the formula here. It shows you how to find it. So the way they calculate that original amount when we have flat rate is it's normally a percentage of the original amount, so the initial value. So you can see there in the formula, so you might just want to write next to it. So R is probably going to be a percentage rate, and we normally say it's the per annum rate when we use the letter R. If it's if we want to say find a monthly rate, we'll say R divided by 12 and things like that. We'll look into that later. So, and then you can remember that VO is the starting amount if you want to write it, or the initial amount. Okay, so we have, and there's the graph down there again of showing the straight line. And obviously when you there's a few formulas here if you have to calculate, say, something. So say you know what the D value is. So you know D and VO. This is the formula you could use to find the rate. So if you have to find the percentage rate. And here's the formula if you need, see that one? That is actually what we've got up here. So that's just written a bit different. And then here's the recurrence relation just written again. That's just a summary. Bit of overkill there, but anyway. All right, so let's have a look at the example, and I'm going to show you, because they have to tell you what type of depreciation or what type of financial situation we're doing. So it says a new car was purchased for $24,000. So start, when you read through the questions, because I know that was the initial value, I'm going to start writing, all right, that's VO. Okay, and the car depreciates at 20% off its purchase price. So this is where I really want you to highlight this bit, because when it says, I think, of its purchase price each year, so off its purchase price. So that means 20% off the original price. So I want you to meet, that is another way of indicating, this is a way of indicating flat rate. So sometimes they say flat rate. Sometimes they'll say that. So we now know flat rate, oh sorry, not that one. Flat rate is a percentage of the purchase price. That's another way to say that, okay? So we've got to be careful with that. This is one of the ones where it either will say flat rate or it will say that. So when the purchase, what you originally got it for. Okay, so then also they gave me 20%, so I know that's the R there. And it's asking me to create a recurrence relation. So they've been nice and they've put the recurrence basic formula for a flat rate there. So we're going to fill it in now. So the VO, so what was the initial price of this in this scenario? We've already like highlighted it and we've got it ready. So VO was 24,000. And then we're going to write the VN plus 1 rule. So if you look back on your summary notes or even on the previous page, you can see that the D in the formula was highlighted. That meant we need to, when it's highlighted, it means you need to calculate something there. So I'm going to use this formula, which was also in your notes, but we're going to use that formula to calculate what D is. So D is equal to the rate, which I can see is 20 over 100 times 24,000. So what's that that's gonna end up being 480, yes, or 4,800? 4,800 even? Okay, so we know that D is 4,800. So then now I can finish off that recurrence formula. So VN, you write VN, and I actually have to write, because the D is something I had to calculate, and I write it like that. So there is the recurrence relation. So unless you have those two things, you won't get the mark, and it'll probably be only worth 1 mark. So even though you've got to write 2 things, those things have to be present to get the 1 mark. Okay, so then we look at, here's another one. It says flat rate depreciation of a car is modelled by. So as I said, they told you, they will often either tell you. So it's flat rate. So flat rate means it's the same amount taken off every time. And you can see it's 4,800. So this is the scenario of before, just about. So it says use the model to determine the value of the car after 2 years. So this is a case where they often say using the recurrence relation. So I'm going to say that because they're saying model, but they'll probably say using the recurrence relation. They'll say show the value. So this is a case where you must write out all the steps. So we want to see the value after 2 years. So first I'm going to say V1 would equal 24,000 minus 4,800. Okay, so then we get that is, what's that, 1920. Okay, so then you have that. Then you have to show that V2 would be 1920. Oh, sorry, 19,200. I've done too many now. Minus that. So you have to show the stepping out. And what does that equal? You're not getting that 1 mark. So here we go. So we get, and that's the value after V2. So that's me using that. Now, if the car was purchased in 2014, so then you know that this was 2014. It says, in what year will the car's value depreciate to 0? So you could just keep pressing it recursively, and this is probably at this stage they wanted you to do it, but what we're going to do is we could use the nth term formula, which we're about. So I'm going to just, so what you probably with B would have got up to, and you've gone, all right, when you've got to find it after so many years, you could use the nth term formula, and this is the nth term formula for flat rate, which we'll see, we're going to go through on the next page. But just to show you, now I want the car's value to be 0. So what in this, that means the VN, I want it to be 0. We know it was originally 24,000, and we're going to minus 10 times, what was the D in this scenario? What was always getting taken away? 4,800. So you could get up to this part, and then we can just use solve and find that value. So we get it to be 5 years. Okay, so you can say after 5 years. Or in what year? Yeah, just say 5 years, in 5 years. Just in 5 years of time, that's fine. I think their language is probably a little bit off there, and they will make in the 5th year or whatever. They will look at here. All right, so we just saw then an example. So flat rate can have its nth term formula as well, and that was it here. So you can see, because these bits are highlighted, they're the bits that you're going to have to calculate. If you were told to write the rule for the nth term, you will have to substitute in VO, and you'll have to substitute in what the D is. And here's the value, and here's the formula for D. So you'll notice on your summary sheet, there it's all there in like that in there. All right, so let's have a look at this question. It says, the following recurrence relation can be used to model flat rate. So you will be underlining that and know that you're in your flat rate rules. Okay, for a set of furniture, and here's the recurrence relation. Yeah, and it says that this demonstrates the value of the furniture after n years, because you need to know what n is. N could be months, it could be weeks. In this time, it's years. So let's look at A, and it says, what is the initial value of the furniture? So they're just really asking you to interpret that recurrence relation. So what's the initial? Initial means VO, so what's VO? 12,000. So 12,000 was the initial value of the furniture. Now, and how much does the furniture decrease every year?
1,200.
Yeah, so, and it decreases by 1,200. So this is the way of getting around, making sure you can interpret the questions. So write down a rule. So when they say rule, that's most like you got to do the nth term for the value of the investment after n years. So I'm going to be using this formula up here, and I know, so I'm just going to write, all right, Vn equals, and I'm going to, instead, I have to change the VO to 12,000 minus n times D. But I know D is 12,000. I can see that in the formula. So I just like to put the letter after it. So there you go. I've written down a rule for the nth term. And then it says, use the rule to find the value of the investment after 6 years. So what they're asking you is to find V6. And if I was using that above the rule, just above it, so every time in the rule where I see an N, I put the number 6. So it'll be times 6 here. And we can do that, and then we'll find out what was the value. So it equals 4,800. All right, cool. Got that one done. Okay, D, how long will it take the furniture to decrease to 0? So this is a scenario like before. So I would still use the nth term, and I'm still going to use the nth term formula, which is this. I'm just going to write it out again. But I actually want it to equal 0, and n is what I'm trying to find out. Okay, so we can just pop in solve in our calc and comma n, and we'll get the answer. So you don't ever write on your paper the solve function. Okay, so that's why I changed the color. You just have to write what the in black. I'm just helping you to do the other one, a solve function, so you know how to quickly do it on your calc. Alright, so what does that end up equaling? 10. So n equals 10. So how long does it take the furniture to decrease to 0? So we just say 10 years. Okay, and the last question, if a photocopier in the office costs 6,000 when new, its value depreciates at a flat rate of 17.5%. What is its value after 4 years? So this is pretty much doing, you've just got to create a new nth term formula. I'm just going to move this up, sorry. So we're going to do, but it's with a new scenario. So if you look, we want to know when the photocopier depreciates, or what it's its value after 4 years. So I want an nth term, I'm just going to use an nth term formula, and that's up here. So it says Vn equals VO, so in this case it was 6,000, and we're going to say minus, and it'll be N times D. Now I'm just going to put the formula for D in brackets. So it was 17.5 over 100 times the VO, which is 6,000. So I could do that all in one go, and we want it to be, and then you want it after 4 years. So you could actually change that to 4. And you can still put the whole thing in like this. And sometimes I think that it's actually probably better that you do that in your calculator, because then you can actually, when you're going back, you can see what you actually did. And you could edit it if you've stuffed it up, or if they say, oh no, next scenario, it actually changed, and you could just quickly edit it. So it's good to just write it out like that in the calc. So let's do that. All right, so it ends up being 1,000. No, so it ends up being 1,800. So maybe just take note that this was the D value that I used from up here. Yep, the D part of the formula. This is the second type of linear decay that we've got here, and if we look down at the graph, it still depreciates with a straight line going down. But the thing is, the N is actually the number of uses. So you know how before with flat rate, it was actually a time period? Okay, so with unit cost, it's the number of uses, okay, along that the N is. Not like in flat rate, it's a time period, like years or months or whatever. So unit cost, it's how many times you use the machine. So a lot of these things like, you know, they'll use like for lawnmowers or hair dryers, because if the value of the item, it probably wouldn't go down if it's sitting there not getting used. But the more it gets used, the more it depreciates, okay? So what they say is that every time it gets used, it depreciates in a certain amount. So sometimes they say it for like even like a caravan, like so you buy a caravan and they often say like that depreciates how many times you've taken it out on maybe on the kilometers it's traveled. And so the kilometer is the usage, how many kilometers, okay? So we've got the unit cost, so there is calculated based on units rather than time. Okay, so if you look at the formula, the recurrence formula, it's very similar to the flat rate, except that the way you calculate D is different. D will actually be given to you in terms of they'll tell you how much it costs to use it or how much, you know, per kilometer. So if you want, you might write a little note. This will be given or given. This is given or told. Okay? You don't actually calculate the D. They'll tell you what it is. All right. So, and down here, there's a few little ones if you're trying to find out a few little change around, but don't worry about that. Keep going. Okay, let's have a look at this one. So a professional gardener purchased a lawnmower for $270. So here we go. I've been given VO. The mower depreciates in value by $3.50 each time it's used. So see, each time it's used, this tells us its unit costs. Yeah? This tells us that it's unit cost. So you can go to your unit cost formulas and you can use them. Okay, so here's the model, and they've written that out there for us. This is unit cost thing. And it says model this scenario in a recurrence relation. So recurrence relation, you always have to have your VO. So the lawnmower costs $270, and then I have to have my VN plus 1. So which is, you'll put VN and you've got to do minus D. And you'll see on the previous page, only D was highlighted, and that's what I have to put in or work out what that is. And how much does it cost every time you use it? $3.50. So just be there. Now just write a little note. Be careful with use costing, because it's sometimes given in cents, and the formula is in dollars. Okay, so the depreciated value of the lawnmower is modeled by here, so we've already worked that out. Use the model to determine the mower after 3 uses. So they want us to use the recurrence relation, so I've got to do it like we always got to do it. So I'm going to say V1 equals 270 minus $3.50, and that would equal 266.50. Okay, and then you go V2 will be 266.50 minus $3.50 equals 263.00. Make sure you keep putting 2 decimal places. Why am I saying 2 decimal places? Yeah, cents. So in finance, we're always talking about a value. We don't go past cents. So two decimal places is going to be assumed that you do it, okay? So make sure you do that. And then the third one, 263.00 minus $3.50, and that would be 259.50. Okay, so that's us showing us that. And then in B, it says how many times can the mower be used before it depreciates to less than 250? You probably just, in this case, when they're doing this, because you've already recursively done it, you could probably just be doing this one on your calculator. So we'll do a practice of that. So remember where we set the first one in and we press enter and we put it over here, and then we'll say answer minus $3.50 and we'll press enter and we should get our 26.50. So you keep going down until you got to under. Alright, so we kept going down till we got under 250, and that was after 6 uses. Good. After 6 uses. And someone asked me, do you have to write this out? You don't. I was just showing you what we would be typing on our calculator just to help you. Alright, so obviously unit cost has an nth term formula as well. And here is the setup for it. So D will be the cost per use. Okay, so if we have a look at this, a hairdryer in a salon was purchased for $850, and the value of the hairdryer depreciates by 25 cents. So this is where I'm talking about. They're gonna that hairdryer was $850, but its usage is in cents. So straight away, I'm gonna change it to 25 to the dollar. So it's actually 0.25, and it depreciates by 25 cents every hour it is used. Okay, so it says let VN be the value of the hairdryer after hours of use. Okay, so write down a rule for the value of the hairdryer after n hours. So because they said rule, that would mean you're doing nth term. Okay, so we'll go up there and we've gone to our summary sheet, and we've found this formula. So I'm going to write Vn equals the VO, which is 850, minus n times D, which is, I've worked out, is 0.25 times n. Okay, all right, so I changed that to cents. And then it says B, write down what is the value of the hairdryer after 50 hours. So that would be V50, and then I use this formula up here. So 850 minus 0.25 times 50, which would be, what does that equal? Okay, so the value of the hairdryer, yeah. So anyway, so you just write that. So that's B, 800. So someone asked, do you need the dollar sign? You don't need the dollar sign, but you will need 2 decimal places for the cents. And C, on average, the salon will use the hairdryer for 17 hours a week. How many weeks will it take for the value of the hairdryer to half? So first of all, if the value is half, what will the value be? It'll be 425. So let's find out, using the nth term, how much how many hours it's going to take for it to be 425 first. So we're going to write out that formula, and this time it's going to be n that we don't know, and we can use the solve, comma n, and we're going to find out how many hours that is, because this formula is an hours formula. All right, so I get this to be 1700 hours, but it's asked me how many weeks. So 1 week equaled, they use 17 hours. Okay, so if I do the total, the 1700 hours, and I divide it by 17 because that's 17 per week, we end up with 100 weeks, yeah? So after 100 weeks, that hairdryer is half the value.